All right, so number 15. This one I have hoping I was trying to come up with one that might be a little bit harder, make you think a little bit here. So you're prepared for whatever question you might get. It says here the doubling time of E. coli bacterium is 20 minutes on a continuous exponential growth model. Pause. They just told us what formula to use. Continuous exponential growth model. Look on your formula chart. What is the continuous exponential growth model? N equals KT, where K is the rate. On this one, it says the doubling time, or it says meaning the population doubles every 20 minutes. Suppose the colony begins with a population of 5 bacteria. What variable would that be? NO is 5. And I skipped something, 20 minutes. What will that be? T. What equation population the population growth if T is in minutes? So to solve this, you actually have to find something out. Right now in the formula, I have 2 variables. K is the rate. Do we know our rate? No. And N is the final amount. We don't know that either. So here's how you solve it. It says the doubling time is 5 minutes. So if the population was going to double, I could say N would be, what's 2 times 5? 10. So here's how I can solve this. I can say 10 equals 5 E. I don't know K, but I do know T. The doubling time is how many minutes? 20. So I'm going to say 20K. Instead of doing K20, I'm going to do 20K. Let's insolve this. How do we insolve? Y equals 10. Not going to do mental math since I really messed up the last problem. We're going to do it this way. Let's type this in and see what K is.
You're not sleeping.
So Y equals 10 and Y equals 5E to the 20K. I don't see it cross. Why do I not see an intersection?
You have to zoom in.
Yeah, I don't go up to 10. I just need to go up to 10. So when I zoom in, I want to make sure I get the intersection. I'm getting 0.0347. Y'all might be getting that, or I might round it off 1 decimal, depending on how far you zoomed in. The more you zoom in, the more decimals it'll show you. So I'm getting 0.0347. That is our K value. K is 0.0, what did I say? 347? Okay. So for your answer, though, it says what equation models. If they're doing an equation, then they would say N of T, meaning the N would change depending on how much time there is, because the population is always growing. So they would say N of T in the answer choice. N of T meaning the population after a different amount of time. How many, come on in, how many, what's our initial? Wherever. What's our initial? 5. E raised to the power of, this time instead of saying we don't know how much time is taken past, so the answer would just be 0.0347 T. That's how you could find out the population after any amount of time, whether you wanted to find it after 10 minutes, 5 minutes, an hour, 2 days, whatever. That's the formula you would use. All right, so now I have one for you. DOL number 7. Number of downloads of a new song grows at a compounding rate during the first week after the song's release, as shown in the table. So compounding rate. Which function is used to find N of T, the number of downloads after T days? It's growing at a compounding rate. So you can find your formula and go from there.